So let us come back and do the nitration property of your aniline. So till now we've studied the halogenation, that is your bromination of aniline. Let us start with nitration. So whenever in the exam, if you're asked to do the nitration procedure, for nitration of aniline, you require a nitrating agent. That is understood, isn't it? So the nitrating mixture which we are going to use is nitrating mixture, which we are going to use concentrated HNO3 plus concentrated H2SO4. We already know the electrophile which this is going to supply. You have studied in grade 11 even the small mechanism where you're shifting the NO2 plus group, right? So NO2 plus cation, I'm sorry. So the electrophile which is going to supply is NO2 plus. Done. Now first important thing, aniline does not undergo nitration directly. First reason is aniline, when you're trying to allow it, or if you're allowing it to undergo nitration, it just directly gets oxidized. Most important thing, yes, you have to note it somewhere. Aniline gets oxidized on direct nitration. That's why what do we do? First we are going to introduce or allow it to undergo acetylation process. So this is again the same like earlier one. First you acetyl. Why are we allowing it to undergo acetylation? Then with acetylation we'll lock this compound, this particular thing. Yeah, and amine I'm going to lock. Then I can easily nitrate it. So acetylation can be performed by using CH3COCl or even acetic anhydride also. So here what am I going to do? See, either CH3COCl or here I'm going to use acetic anhydride. This is acetic anhydride. So what happens? This acetic anhydride, this will go and break up this bond. And what do you get? You get first, this will lock amine. It will form NHCOCH3. What's the earlier video? I've shown you how HCl has gone out. And so now what is this compound? This is called acetanilide. So this acetanilide, now I'm going to introduce this nitrating mixture, right? So that will supply your NO2. So you are going to add concentrated HNO3 and concentrated sulfuric acid. When you're adding these two, the electrophile NO2 will go and just occupy the ortho position, para and ortho. You'll get both the products. Because of resonance, we have already seen this is already locked NHCOCH3. You get one at ortho position. This is ortho nitro acetanilide plus para nitro acetanilide. These two are the products. Acetanilide. Done. So still our nitroaniline is not formed. So this further, now which is my minor in this is minor product, this is major product. Then we are going to further hydrolyze it. Yes. When you have further hydrolyzing it, we very well know this particular acetic acid comes out. Here also you have CH3COOH. If I take 2 moles, suppose if I take, let us assume I'm taking 2 moles. 1 OH here, 1 OH here, 1 hydrogen here, 1 hydrogen here. So what do I get? Again I get 2 products. One is here aniline, that is orthonitroaniline, O-nitroaniline, which is a minor product. After that, I am also going to get para-nitroaniline, which is a major product. This is your major product. That's it. So this is how you're going to do nitration. Never in the exam, please don't directly take your HNO3 and do the nitrating procedure. Wrong. You lose mark for that. First try to form acetanilide, then only convert into orthopara. After orthopara, further hydrolysis. So what is the reason? Aniline undergoes, I'm writing the same reason here, aniline. Okay, aniline. What in aniline? What is this? Your whole thing, amine, right? And this amine part undergoes oxidation. Hence, it is allowed to form these compounds.